All right, so here's our formula for finding for a confidence interval for the mean of a sample. All right, because x bar plus or minus z times sigma over root n. So we've already talked a little bit about some names, but I'm just going to share a couple other names with you, so just that you don't get confused. Sigma over root n is standard deviation of a statistic, and sometimes you'll see our book and other places refer to it as standard error. All right, again, error not meaning, oh, we did something wrong, but this is how far we are away from something. We're not exactly on, we're just close to it, so that's error. So standard error is the standard deviation of the sampling statistic for x bar. It's sigma sub x bar. All right, so it's also called that. All right, and this whole thing is referred to as the ME, or the margin of error. The margin of error. And what we can do is say, well, we can actually start talking and say, well, if I want my margin of error to only be, let's say we're estimating heights of something, and I want to be within 2 inches of something. So let's say we're estimating heights of people, and I want to have an estimate that's going to be within 2 inches. All right. When they say within 2 inches, what they're meaning is I want my margin of error. That's a terrible M, even by my standards. I want my margin of error to be less than or equal to 2. I don't want to be any further away than 2 inches when I'm making my confidence interval. So again, let's think about this. So if I'm doing something like a 90, let's stay with 95%. We've been doing 95 all along. 95%, we look on the Z table or at the bottom of the T table, and we see it's negative 1.96 and positive 1.96. All right, so that means I'm going to substitute in z times sigma over the square root of n less than or equal to 2. And they go, oh, this is 1.96. And let's say that we know that heights, have a standard deviation of 4 inches. All right, we're going to say, okay, so that's going to be times 4 over the square root of n is less than or equal to 2. What I'll be able to do then is use algebra to find out how many people do I need to have in my sample in order to have an interval as narrow as 2. All right. So again, we just kind of keep going with this, and we do algebra. So 1.96 times 4. I'm going to multiply both sides by root n. Multiply over here by root n, so that way root n over root n change. 1.96 times 4, 2 times 4, this is, just under 8. We're going to say it's about 8. I don't have my calculator. Less than or equal to 2 times root n. And then I divide both sides by 2. I'm going to have to bring this over here. We'll go up here with it. So I divide both sides by 2, so then I have 4 less than or equal to the square root of n. And then I square both sides. So in order to get a margin of error of no more than 2, if I want to be within 2 inches total, I would need to sample at least 16 people in my sample to have a margin of error of no more than 2. So if I have a margin of error of no more than 2, that means my interval is no more than 4, because it's plus or minus 2. All right. So that means I am within 2 of the actual mean. So I'm 95% confident that the actual mean height is somewhere in this 4-inch total width interval. All right. So when we're doing this, then we can extend that on, and let's do it to proportions. All right, so a proportion interval is p hat plus or minus z times p q over n square root of the whole thing. All right, so then I want my margin of error. This is like political polling. If I want to be plus or minus 2%, that means I want z times sigma over pq over n to be less than or equal to 0.02. All right, and now let's say we're going to do a 99% confidence interval. All right, a 99% confidence interval. Let me grab my table here. So 99%, looking on the t-table here, is 2.576. So I have right here 2.576 times PQ over N less than or equal to 0.02. All right. If I do not know anything about P and Q, this gets down to like, how do I know what to use? Typically in a case like this, where we know nothing about our original p, because I'm really looking for it, I don't know where it is exactly, I'm going to use 0.5 and and then 1 minus 0.5 is 0.5. I'm going to use those two numbers to be my most conservative estimate. They'll give me my largest number in the numerator, so it's my most conservative, divided by square root of n. All right, so then, again, I need to do some algebra. I divide both sides by 2 here's my calculator. 0.02 divided by 2.576. So on the right here I have 0.0077 less than or equal to 0.25. That's 0.5 times 0.5 n square root of the whole thing. So I square both sides, and I have now 0.25 over n less than or equal to a number on this side that I'm not going to write down. Multiply both sides by n. All right, so this number times n, so here my n's reduce, and then I take and I divide both things by whatever this number, what this was, by the way, I did it in my calculator, 6.03 times 10 to the negative fifth. Not an easy number to write down, but anyways, I'm then going to do 0.25 divided by that number to get n all by itself. And I find out that if I want to do that, n must be at least 4147.4. So basically, n must be at least 4148. In order to have an interval and be within 2% of the actual, so I'm going to say I am 99% confident that the actual p, the actual proportion of everybody that approves of this thing, is within 2% of the actual population value. I would need to sample more than, or at least, I need to sample at least 4,148 people to be that precise. Remember, to make a more precise interval, I need to sample more things or more people or more whatevers. All right, the more I sample, the narrower the interval. And again, the reason why is the more I sample, as n gets larger, I'm dividing by a bigger and bigger number, which makes the standard error smaller. As n gets larger, the standard of error gets smaller. As the standard of error gets smaller, my margin of error gets smaller, and so I can have a narrower interval. All right, so those are the basic ideas of how to select a sample size. In terms of what to put in your reflection response, I don't have anything this time, so there's no question you need to answer, but you still have to write down questions. Still fill out the reflection response. What question do you have about everything I've just presented here? If you are spending time thinking, you will have something to ask. All right, so do that, and I will see you in class.